My name is Michael D'Antonio, and I'm here on behalf of the Maryland Power Electronics Laboratory Electric Vehicle Team. I'm here today to present an integrated onboard charger for electric vehicles that's a market-driven solution to promote sustainable transportation with the future capability for smart energy distribution. I invite you to, okay, how do we go next? Sorry. Yeah. Oh, okay, there it goes. Okay. So I invite you to meet our team of highly experienced electrical engineers, all pursuing PhD degrees at the University of Maryland in College Park. While each of us has contributed something unique to the project, we're collectively passionate about sustainability in electric vehicle development and the future impact that the growing technology possesses. And obviously, we've identified our need for a bit more business-focused leadership. For right now, we've filled this void with the help of two fantastic mentors, including Akbar Dawood and Lindsay D'Ambrosio, who have excelled at startup-level businesses and offered valuable experience thus far and connections moving forward. Here's a brief background. Electric vehicle sales constitute one of the fastest-growing markets in the world. Last year, global EV sales were around 770,000, and this was about 1% of total global auto sales. Research has shown that there is a 59% year-over-year growth in the electric vehicle market as well in the future. While the U.S. makes up a large growing market for electric vehicles, China and Western Europe top total sales, which establishes electric vehicles as a truly global market. Data shows that electric vehicles will have a 3% market penetration by 2020, which is the equivalent of about 3 million new electric vehicles in that year. Furthermore, we expect a 15% market penetration in 2020, which means about 17 million new vehicles in 2025 alone. So as we can see from the figure, we're looking at the blue line, the S-curve. The number and percent of electric vehicles is growing at a pretty impressive rate. So the question might be, why get into this market now? Well, the numbers speak for themselves. We're confident that our product will see market exposure within the next 2 years. If we can establish our place in this industry by 2020, we can expect an absolute boom in sales and growth from 2020 to 2030 when it's expected that electric vehicles become cheaper than the alternatives. So in terms of EV technology, optimization of component size, weight, and efficiency is essential. And while major improvements and research are being conducted to deliver a more affordable baseline electric vehicle price, the primary research driving this cost down is the cost of the vehicle's battery. Component cost is often overlooked and could work to supplement reduced battery cost. Our integrated onboard charger is a product that could make improvements into all of the categories listed above. Furthermore, our research project is funded by the U.S. National Science Foundation. So as we can see from the figure below, this is the current existing technology. It's a dual charging solution with an onboard charger to power the high voltage propulsion battery and an additional auxiliary charger for the low voltage battery, which powers auxiliary technologies in the vehicle like the radio, lights, etc. Our solution is a combination of the two into one. And the technical comparison can be seen in the following slide. It's not going again. Oh, here we go. Okay, so in this image we see a more technical breakdown of exactly what the existing solution looks like. Again, we see the dual charging solution and the addition of the communication required between the two independent chargers. On the right, again, we see our solution, a much more compact design. Speaking about the technology itself, our design is a 3-port charger using a half-bridge resonant design and integrated transformer. All this means is we're able to achieve high efficiency over our entire operating range. We see that existing solutions have poor light load efficiency. And this is a crucial flaw because around half of the charging cycle is done during the light load operation period. That's because the charging cycle is heavy during the beginning and middle, but it slows down towards the end to protect the overcharging of the battery. And we can define light load as being around 10 to 20, 30% of the total rated power of the charger. In terms of control, as I mentioned, we have the mitigation of the required communications between chargers. With size and weight, we reduced 2 large, bulky chargers into a single, efficient, high power density device. In cost, we replaced 2 products with a single one. And finally, in power direction, this is our novel achievement in this product, bi-directionality. Bi-directionality is the ability to charge and use the high voltage battery for vehicle propulsion, as well as the included capability to send energy outside of the vehicle when for some other purpose whenever you need to. So this has serious implications for grid stability and the microgrid ideas, giving our product a truly future-driven capability that will certainly be commonplace for vehicle technology in the coming years. This is a prototype of our integrated onboard charger, and we can have a sense of appreciation for the condensed size and organization here. Here are the performance metrics for a current Barusa onboard charger, and below is our technology. As we can see, we've designed the voltage and power ratings to be similar. However, I would like to highlight the improvements that we make on the size and performance metrics. We can clearly see reduction in weight and size, improvement of maximum efficiency, and improvement of light load efficiency, as we mentioned, is incredibly crucial in the last section. Furthermore, the price difference speaks for itself. As a summary of the previous slides, we've quantified exactly how much we're improving. So we have a 58% cost improvement, a 2% maximum efficiency improvement, 7% light load efficiency improvement, and a reduction in size and weight by 43% and 30% respectively. Now, we also have value propositions for consumers that look like the following. With our component, consumers can see a lower baseline EV cost. They can also see reduced charging time and charging costs because of our improvements in efficiency. Now, studies have shown that an 8.5% improvement in light load efficiency will reduce your EV charging costs by 1 full month per year. This is 8.5% above 83%. For the current technology. We're at 7% improvement, and we're currently working to get to this 8% mark. Furthermore, we can see a reduction of greenhouse gas emissions because less energy is needed to charge each individual electric vehicle. Now, speaking of our market entrance, we want to operate as a product licensing to OEMs and EV manufacturers. First, we have a company named Genovation Incorporated. This is a small business green electric vehicle manufacturer headquartered outside of Washington, D.C. Following the verification and establishment within Genovation, we want to extend our technology to other OEMs and EV manufacturers. And like I said in the beginning, and I'll repeat again, this is truly a global business. There's over 30 companies producing electric vehicles at this time, and most companies are producing more than one electric vehicle. And this number is only going to go up. And as you can see, some of the companies include some of the ones that you've probably heard before. In terms of barrier protection, we have a patent pending on our product. And I'd like to notice that the patent includes both the integrated capability as well as the bidirectionality feature. Now, it's important to note that the patent that we have is technically owned by the University of Maryland. However, the company that we will form within our team has exclusive rights to this patent. In terms of projections, we expect that we'll need an original cash infusion of around $250,000 to $300,000 based on the 1-year period we expect until we could roll out our product to Genovation. While there's some funding resources included below, this money will go primarily to the conclusion of product development, company formation, investor search, and customer discovery, our next big thing. In terms of the financials, the parts involved in our product cost around $800 now, raw costs. And then we can assume an additional $200 for hidden costs as well. So this puts the total cost per unit at around $1,000. We selected a suggested retail price of $1,500, and this is about half of the current price for wholesale Barusa chargers that we mentioned previously. Finally, we selected a license fee of $70 per charger. This can be simply seen as a 5% royalty on every product sold. So again, assuming a 3% market penetration in 2020, which is about 3 million new electric vehicles worldwide, if we were in every vehicle in 2020, our market potential is about $210 million, considering this $70 license fee. And that's 3 years from now. Below, I have some projections. These are realistic projections. In 2020, we expect that we could make about 5 million, and by 2025, we could reach upwards of 100 million. This 5 million in 2020 is 2.5% of the total electric vehicle market. And what this comes down to is technically 1 or 2 of the 30 companies producing electric vehicles at this time, a realistic estimate. But going back to a summary of our product, electric vehicle market is generating massive traction on a global scale, and it has a large growth year over year. The combination of our 2-charger technology into a single onboard charging unit for electric vehicles is truly unique and leads to efficiency improvements, cost, weight, size savings, and the bi-directionality feature that's truly a future component. Our global licensing strategy to OEMs and EV manufacturers guarantees a high profitability in terms of our financial projections, and we have a patent-protected technology to ensure our lifetime. Finally, with the $50,000 cash prize from Allegheny, we would conclude the development of our OBC prototype and do some final testing. We would do our company formation because the funds that we get here are not restricted to solely research and development. And finally, we do a commercialization plan and search for other investments. And I want to leave you guys with one quote. Not quote, really, but just a sentence. The complete electrification of vehicles is the future of the world. And advanced charging systems are one of the key enablers to make this a reality. Thank you. Thank you.